All right, it's Mr. England. I got the key for this week's homework assignment. Here's my face. You don't need to see me for the answers here. So let's go through this. All right, so first two, I like these two equations. Let's do this one first, and I'll come back to this one and tell you why I like them. Again, we just want to make sure these are all correctly written, so just have to balance them out. Okay, so you just count them up. Okay, the arrow is like an equal sign. So two hydrogens, that's good. Two oxygens, O2. There's only one here, so you have to put a 2 in front. You always have to change the number. You can't change what it is. But once you put a 2 there, you got to come back and put a 2 here. So 2 hydrogens plus 1 oxygen will make 2 waters. All right, come back over here. We got number 2, zinc plus HCl. That's hydrochloric acid, makes zinc chloride and H2. Again, that's what it is. You can't change what they are, so you have to change the numbers of them. All right, so in this case, 1 zinc, 1 zinc. Great. 1 hydrogen, 2 hydrogens, so you got to put a 2 here. Okay, but now you've made 2 chlorines, but that's good because you have 2 chlorines there, 1 zinc, so that's all you have to do for the second one. All right, now I like this because do this reaction in class, it produces hydrogen gas. You can collect that gas, and then you can react with the oxygen in the air to make water, but you really don't make much water, but what you do is you produce a kind of an exothermic reaction or a little bit of an explosion. So that's kind of cool. So hopefully we'll be able to do that someday. All right, here we go. This one I like, sodium, a metal, okay, kind of explosive reactive metal, chlorine gas, which is a nasty gas used in World War I as a toxin, but it will produce good old normal sodium chloride. So what it produces can be vastly different from what these substances are. All right, so that's kind of cool. All right, here we go. 1 sodium, 1 sodium. We're cool there. 2 chlorines, only 1 there, so you got to put a 2 there. But once you put a 2 there, you got to come back and put a 2 there. You don't have to put a 1 because it's understood to be 1 if you don't put anything there. Next one, you can make silver out of copper. It's kind of a cool reaction. Again, I wish we were in the class we could do it. But if you count them up, it's already balanced. 1 copper, 1 copper. 1 silver, 1 silver. 1 nitrogen, 1 nitrogen. 3 oxygen, 3 oxygens. Okay. For those of you who did nothing, you got 1 right. Good job. All right, here we go. This is a reaction that makes fertilizer, okay, which allows us to have a bigger population in the world. It's called the Haber reaction. Okay, 2 nitrogens, only 1 over here, so we got to put a 2 in front there. Now that's kind of nasty because now we have 2 times 3. You have 6 hydrogens. Only 2 here, so what times 2 is 6 is 3. So 3 times 2, 6 hydrogens there. 2 times 3, 6 hydrogens there. That's good. Okay, next one, magnesium and oxygen. All right, so 1 magnesium, 1 magnesium. Good. 2 oxygen, only 1 there, so you got to put a 2 in front there. Come back and put a 2 there. Got it done. All right, this tricked a few people. Here we go. Here's the trick. So you got something all by itself. Usually you can wait till last to do that because it's going to be easy to balance. 2 oxygens here, 3 here. You pick a number they both go into, which is 6. So 3 times 2 is 6. 2 times 3 is 6. So the oxygens are balanced. But now I've got 2 times 2 or 4 aluminums there. So I got to put a 4 in front of the aluminum in front. Now that's balanced. Next reaction, that's propane gas. That's what's in like gases for propane heaters, for barbecues and so forth. C3H8. All right, so do that carbon first. 3 carbons, only 1 here, so you need to put a 3 there. So carbons are good. There's 8 hydrogens there, only 2 here, so I need to put a 4 there. 4 times 2 is 8, so that's cool. Here oxygens, there's 2 oxygens there, and on this side you got to add them all up. 3 times 2 is 6, plus 4 more. 6 plus 4 is 10. What times 2 is 10? Well, 5 times 2 is 10, so you put a 5 there. So balance 1, 5, 3, 4. Next one down, here we go, Ki. All right, let's just do the potassiums first. 1 potassium, 1 potassium. 1 iodine, 2 iodine, so you got to put a 2 here. Now once I put a 2 there, now I have 2 Ks, so I put a 2 there. And lo and behold, look what happens. You got 1 lead, and you have 2 of these nitrate groups, NO3, it's a polyatomic ion. You have 1 here, but 1 of these times 2 is 2. So that's all you have to do, and you're balanced there. And the last one, that's responsible for life. Hey, that's photosynthesis right there. All right, so 1 carbon, 6 there, so I need to put a 6 here. Okay. I have, so carbons there, 2 hydrogens there, 12 there, so I need to put a 6 there. Now oxygens could be a little difficult here, but I have 6 times 2 is 12, plus 6 more, I got 18 total on this side, 18. Over here, I have 6 here, plus 2, I have 8. So what I can do is take that 18 minus 6, know that I got to come up with 12 here, so if I put a 6 there, that'll do the job there. That's a little tricky there, but I was impressed. A lot of you guys got that. All right, so there's balancing equations. Just check on those. If you have any questions, make sure you email or give me a call. Have a good weekend, and we'll see you next week.